Geology in a Jiffy! What's in the bag? It's
Transform faults. Transform faults are a special type of strike-slip fault. Transform faults happen when two blocks of rock move in relation to each other at a fault plane by them sliding past each other, like this, or like this, but not up or down. But transform faults are special for two reasons. The first is that transform faults do not occur between blocks of rock. Instead, they occur between sections of tectonic plates. And secondly, as with typical strike-slip faults, the movement is not always in opposing directions. Instead, the sections of plates can slide past each other in the same direction, so that over time, as one section of plate creeps forward in one direction, its neighbouring section then also does so too, with both sections moving in the same direction. Where do we find transform faults? Let's look into an ocean and see what is beneath it. We will see ocean floor, which when studied is made up of oceanic crust that sits upon the mantle. In the mantle, upwelling convection currents put strain on the overlying oceanic crust, the magma moving upward until it fractures the crust, forming a spreading boundary. As the boundary widens and the plates move apart, more magma is injected upwards. If this happens with two neighbouring sections of plate, and our spreading boundary cuts across both sections of plate, then they would move equally if the spreading was at the same rate. However, if the spreading on each section of plate was unequal, then the spreading ridges would become staggered. Let's look at such an area between these plates, and study the movements of the sections of crust about this point. This plate here is moving down to the right in relation to the ridge, and on the opposite side of the fault, this plate is also moving in the same direction, resulting in both plates sliding past each other in the same dextral rightward movement. If we look at the area beyond the spreading ridge, at the plate boundary, this section of plate is also moving up to the left, as is the other plate too, giving an overall sinistral leftward movement. And when we compare both sets of movement together, we see the overall motion is of a spreading plate boundary. However, if we study the area between the offset spreading margins, we see this plate moving down to the right, and this plate is moving up to the left, making this section of the plate boundary a strike-slip transform fault.
wow!
Transform faults must be connected to other faults or tectonic plate boundaries on both ends, and because of that requirement, transform faults can grow in length, keep a constant length, or decrease in length. When we study this famous graphical image of the floor of the Atlantic Ocean, we can clearly see the transform faults offsetting the spreading boundary that is making the oceanic crust, the transform faults enabling the sections of the Earth's crust to slide past each other over many millions of years.
That's amazing!
Please do watch our other Geology in a Jiffy videos about normal faults, reverse faults, and strike-slip faults.
Please subscribe to my channel. Bye!